Hello viewers, today we are going to solve some important problems in differentiation. So here I have written two problems, and these two problems are very important, and once you are able to command these two questions, you will be able to solve any problem of this type, right? Okay, so let us solve these two problems. Now here the first one is differentiate tan inverse x over square root of 1 minus x square with respect to, see, this is with respect to sine inverse 2x times square root of 1 minus x square. Now here what we will do, we'll first assume that say u is equal to this function, right? So we'll suppose u equal to tan inverse of x over square root of 1 minus x square, and let us say v is equal to this function, right? Okay, so we have u and v as two functions. So our aim is to find du over dv, right? So this is our aim. Now what we will do, first we'll find du over dx. It means here we'll have du over dx, and then we'll find dv over dx, right? Okay, so yes, here we have this function that is u equal to tan inverse x over square root of 1 minus x square. Now here our aim is to make a proper substitution. So let us substitute x is equal to say sine theta, right? So here we'll substitute x is equal to sine theta. So let us see what is the value of this expression when x is sine theta. So here we have sine theta, and we have 1 minus sine square theta, right? So u becomes tan inverse, as this is sine theta over cos theta, because 1 minus sine square theta is cos square theta, and when we take the square root of cos square theta, we have cos theta. So this is tan inverse tan theta, right? Because sine over cos is tan. Now tan and this tan and tan inverse get cancelled, so we have u is equal to theta, right? So from here theta can be written as sine inverse x. So therefore u is sine inverse x, right? Okay, now let us do the same thing for this function. So here again we'll substitute the value of sine theta here. So we have v is equal to sine inverse, and this is 2 sine theta, and then we have 1 minus sine square theta, right? So v becomes sine inverse, and this is 2 sine theta, and this becomes cos theta, right? So v is equal to sine inverse of sine 2 theta here, because 2 sine theta cos theta is sine 2 theta. So this sine and sine inverse get cancelled, so we have v is equal to 2 theta. So v can be written as 2 times of sine inverse of x, right? Okay, now viewers, here we have seen that u is equal to sine inverse x, and V is 2 sine inverse x. So what is the value of du over dx? So if we find the derivative of u with respect to x, we get 1 over square root of 1 minus x square, because the derivative of sine inverse x is 1 over square root of 1 minus x square. Now divided by dv over dx. So we'll find the derivative here. So we have 2 times the derivative of sine inverse x is 1 over square root of 1 minus x square. So this get cancelled. So here's we have 1 over 2, right? So therefore we have seen that the derivative of this function with respect to this function is half. Okay. Now viewers, here we have to differentiate this function with respect to this function. So again, what we will do, we'll take u is equal to tan inverse of this function, that is square root of 1 plus x square minus 1 divided by x, right? And v is equal to sine inverse 2x divided by 1 plus x square. Clear? Okay. Now here again we'll make a proper substitution, and let us substitute x is equal to tan theta, right? So when we substitute x is equal to tan theta, so theta is tan inverse of x, and let us find the values of this expression and this expression when x is equal to tan theta. So u becomes tan inverse 1 plus tan square theta and minus 1 divided by tan theta, right? Okay, so this becomes tan inverse 1 plus tan square theta is sec square theta, and the square root of sec square theta is sec theta minus 1 divided by tan theta, right? So we can write this expression as tan inverse sec theta is 1 over cos theta minus 1 divided by sin theta over cos theta, right? Okay, so here we have tan inverse, and if we simplify this, this is 1 minus cos theta divided by cos theta. Cos theta and cos theta get cancelled, so here we have sin theta, right? Now this is tan inverse 1 minus cos theta is 2 sin square theta by 2, and sin theta is 2 sin theta by 2 cos theta by 2, right? Okay, so 1 minus cos theta is 2 sin square theta by 2, and this is from trigonometric identities. So here 2 get cancelled, 1 sin theta by 2 get cancelled, so we have tan inverse of sin theta by 2 divided by cos theta by 2, right? Okay, now this can be written as, I am writing it here, so this is tan inverse of tan theta by 2, right? This is sin theta by 2 over cos theta by 2, and this is tan theta by 2, and tan inverse get cancelled, so we have theta by 2, right? So therefore u is equal to theta by 2, and theta is tan inverse x, so du over dx is half multiplied 1 over 1 plus x square, right? Okay, now let us substitute here the value of x equal to tan theta. So therefore V becomes sine inverse, this is 2 tan theta divided by 1 plus tan square theta, and we know that this is sine inverse, and 2 tan theta over 1 plus tan square theta is sine 2 theta, right? And sine inverse get cancelled, so we have 2 theta, and 2 theta is 2 times of tan inverse x, right? So here's here I am writing dv over dx. So dv over dx is equal to 2 times of the derivative of tan inverse x is 1 over 1 plus x square, right? Okay, so now we have to find du over dv, that is we have to differentiate this function with respect to this. So what we will do, we will substitute here du over dx as 1 over 1 plus x square divided by dv over dx is 2 divided by 1 plus x square, right? So 1 plus x square and 1 plus x square get cancelled. We have 1 over 2 divided by 2, that is 1 over 4, right? So therefore the value of du over dv is 1 over 4. Now viewers, let us take one more important problem. If sine y is equal to x sine a plus y, we have to prove that dy over dx is equal to sine square a plus y divided by sine a. Now here we are given that sine y is equal to x sine a plus y, right? Now let us differentiate both sides with respect to x, and here we see that this is the product of two functions. So the derivative of sine y is cos y, and then we have dy over dx, and then we'll apply the product rule here. So first function, derivative of this function is cos a plus y, and then by chain rule we'll have the derivative of a plus y, which is dy over dx, right? Plus sine a plus y, and the derivative of x is 1. Clear? So this is cos y, this is dy over dx, and here we have x cos a plus y times dy over dx plus sine a plus y, right? Now taking this term to this side, we have cos y minus x cos a plus y, and we have dy over dx equal to sine a plus y, right? So here's, therefore we can write dy over dx is equal to sine a plus y divided by cos y minus x cos a plus y, right? Now we have sine a plus y, and we have cos y minus for this x we can write sine y divided by sine a plus y, right? And here we have cos of a plus y. So for this x from here we have written the value of x as sine y divided by sine a plus y. So we have substituted this value at this place. Now this is sine square a plus y because we are taking the LCM here, and we have sine a plus y cos y minus we have sine y cos a plus y, and this sine a plus y goes to the numerator and it get multiplied with this term, so we have square term here. Now here we see that this term becomes we have dy over dx is equal to sine square a plus y divided by sine we have a sine a, suppose we take a plus y as capital A and y as b, then we have sine a cos b minus sine b cos a, right? And it becomes the formula for sine a minus b, right? So a is a plus y and b is y, so we have minus y, so y and this y get cancelled, so we have sine square a plus y divided by sine a, right?